So it is called ecliptic plane. Now, when the North Pole points towards the sun, we have summer in the northern uh, hemisphere and winter in the southern hemisphere. Then the Earth goes into the position where both the North Pole and the South Pole are equally illuminated by the sun, and so we have summer, then we have autumn, and then here we have winter. When the North Pole points away from the sun and the northern hemisphere 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 is winter like present, and the southern hemisphere points towards the sun, and that it comes here again. We have spring where both are equally illuminated, and it is come back and over here. So these four positions which are particularly important. So this is the winter, this is a spring, this is a summer, and this autumn. Now we are interested in what this appears from the earth. Sitting on the earth, what does it appears like? Okay, so that is what is of interest to us. Now when we sit on the earth, look at the sky, and it is convenient to define something called the celestial sphere. Okay, so this is a sphere of the infinite radius, and all the objects that we see on the sky we think of as being on this sphere called the celestial sphere. Okay, and the rotation axis of the earth, we ex- extrapolate that. So this is the rotation axis of the earth, and we extrapolate that the place where it intersects the celestial sphere. This is the north celestial pole, and this is the south celestial pole. Okay, just like the north pole of the earth and the south pole of the earth, we also have the north celestial pole and the south celestial pole. And if you take the equator of the earth, which is the plane perpendicular to the rotation axis, and the extent that it will intersect the celestial sphere at the equatorial place. So that is the celestial equator. So the blue curve over here is the celestial equator. It is equator of the earth celestially perpendicular to the position axis. If you extend, that is infinity, the place where it intersects the celestial sphere, and that is the equatorial and the celestial equator. Okay, so we have the celestial equator, and we have the north celestial pole and the south celestial pole, and the whole sky rotates around this. But we are not interested in that the position of the stars remain fixed on the celestial pole in the celestial sphere. So we are not interested in the rotation of the sky. So the position of the stars, this is the sphere that is fixed to the stars. The stars maintain fixed relative position to this sphere. The celestial sphere is fixed to that. Now when I look at the sun sitting over here, sitting on the earth, the what will the position of the sun look like? To understand that, let us go back to the previous picture. During summer, the sun is going to appear to the north. So this corresponds to summer. During the summer, the sun, you can see here, this is the summer, the equator to perpendicular to the rotation axis. So the equator actually points downwards now, and the sun appears to the north. It is fixed. Okay, in this picture, the sun during summer, the sun during the summer, furthest position from the equator is the peak of the summer. Okay, the peak of the summer of the of is the furthest position from the equator. It is called the summer summer solstice. Okay, so that is the summer solstice, and then after summer we have autumn. Is autumn, the sun is exactly perpendicular to the rotation axis. So it is the rotational, so it is the rotational equatorial plane. So the sun has moved down towards the equator, and at atom autumn, exactly in the uh, middle of the autumn, it exactly intersects the equatorial plane, and then in winter sun has moved to the southern hemisphere on the sky. And okay, so now the south pole points towards the sun, and the equator points upwards to, so the sun is now the southern hemisphere. So the sun has moved to the south, and this is the extreme.